Welcome to the lecture. Today I will tell you the direct method, scaled shifted impulses method, and the third one, convolution method of getting the output of the system. You know that when we pass the input from a system, it will always produce an output that is via when. So let me explain the first method, which is direct method, through an example. I have the system, this one, and x of n is this. This means that x of 0 is equal to 1, x of 1 is also equal to 1, and x of 2 is also equal to 1. So I want to find y of n. Let's start with y of minus 1. When n is equal to minus 1, what will be the output? X of minus 1 minus 2x of minus 2 plus 3x of minus 3, which will be equal to, there are no values of negative indexes, so it is 0. When I put n is equal to 0, it will give x of n, x of 0 minus x of minus 1 plus 3x of minus 2. So I have the value of x of 0, which is 1. So it is equal to 1 because all other indexes are negative, which are 0. So the next one is y of 1. Put n is equal to 1. So this will become this one. Now I have the value of x of 1 and also the x of 0. So 1 minus 2 is equal to minus 1. Similarly, y of 2, x of 2, x of 1 plus x of 0. So I have all the values of these three indexes, which is 1 minus 2 plus 3, because all the indexes are 1, index amplitudes are 1. So what's the output? It is 2. And the next one, y of 3, x of 3 minus x of, you can see it is 2 plus 3x of 1. So again this is 0 because there is no x of 3. 2 into 1 plus 3, it comes out to be 1. Similarly, y of 4 is equal to x of 4 minus 2x of 3 plus 3x of 2. It comes out to be 3, because x of 4 is 0, there is no x of 4, there is no x of 3, so x of 2 is there also, so this comes out to be 3. Now if we find y of 5, x of 5 minus 2x of 4 plus 3x of 3. So as you can see that there is no x of 3, x of 4, x of 5. So this comes out to be 0. So what is y of n? Y of n comes to be 0, 1, minus 1, 3, 2, 1, 3, 0. This is our 0 index, and 1 is the amplitude of 0 index. So this was the first method, that is direct method. We calculate the output by direct method. So the next one is scaled shifted impulses. What we do in this method, first we have to find the impulse response of the system. So what will be the impulse response of the system? I am going to write it directly because I have told you how to write the impulse response directly in the last lecture. So it comes to be 1, minus 2 and 3. Here is the 0 index. So you can see that this is our response, and we have x of n as a signal, input signal. When we pass the input signal from the system always have a response. It implies response on the output. So what input and output will be, let me draw it. It is 1, minus 2 and 3, h of n. So in this method, first it will pass through the system and multiplied by the here is 0, 1, 2, 0, 1, 2, and multiply this with the first index of the input signal, amplitude of the first index. This is minus 2, this is 1, this is 3, this is 1, this is minus 2, this is 3. So as you can see that we have the amplitude 1, so it will have no effect on it. Now the next one, minus 2, 1, 3, here is 1, 2, 3. Shift this signal. What is the name of the method? Scale shifted impulses. So I am going to shift it. This is x of n minus 1, so multiply it with the second one, amplitude of the second index. When I multiply it with the second index amplitude, which is also 1, I will get again this signal. And in the third case, what I am going to have the shift of minus 2. So it will shift on 2, 3, 4. So What will be the output? The output will be the sum of these one. As I have written this formula, this will be the sum of all these values. You have to multiply it with the index amplitudes of the indexes of input signal. In this case, I have one amplitude, so I am not going to multiply it with that one. If you have different amplitudes, you multiply it with that amplitudes to get scale shifted impulses. So when I am going to add it, I will get y of n, which will be at 0 it is 1, at 1 it is minus 2 plus 1 minus 1, at 2 3 minus 2. What is 3 minus 2? It is 1 plus 1, it is 2. Then at x, at third index, minus 2 plus 3, 1. At 4, n is equal to 4, it is 3, then 0, 0. So you can see that this output of the system is similar to the previous one, which is obtained from the direct method. So we can use this method also to find the output of the system. So the third one is convolution method. This is very important in digital signal processing. What is convolution? The mathematical way of combining two signals to get the third one is called convolution. I am going to explain it in detail in this lecture. So what is convolution? In convolution, we have input signal and impulse response of the system. Let me write the impulse response again, which was 1, 0 index, minus 2 and 3. So what you have to do in this method, first just flip this one, h of minus n. First you have to replace x of n with x of k. 1, 1, 1. Then replace h of n with h of k. Now flip this one. Flip the response of the system, h of minus k. So what will happen? This 3 amplitude will move to the minus 2 of n is equal to minus 2. It will reflect. It will go to the left side of the 0 index. Now it is on right side. When I apply reflection or flipping on it, it will move towards left. So this is 0 index. So in convolution, I wanna multiply this with, I have input signal 1, 1, 1, and then this one there. So this is 0 index. In convolution, multiply it 1, multiply 1, there is 0, 0, 0, 0. So plus 0, you will get 1. In the next step, slide it towards right one. As you can see, plus n. Slide it over there. Now 1, 1, 1. You can see -2, 1. Now -2 plus 1 comes out to be -1. In the next step, again shift, slide it towards right until the signal goes away. Multiply these 1 and add what it comes to be. It comes to be 2. Similarly, this one, it's 3 minus 2 is equal to 1. Now 3 minus 2, 1, 3, 1, and in the next step it will come to be 0. So what is the output of this one? You can see that at 0 index it is 1 amplitude, and then -1, 2, 1, 3, 0. So it is similar to the one which we obtained from the direct method. So let me explain convolution a little bit more by some theoretical concepts. In convolution, we have two signals. The first one x of n and the second one h of n. I am going to take this example again. Zero, 1, 2, all are 1. So what you do in convolution, just replace this n in the first step with k, this n with k. In the next step, just replace this k with -k. What will be the output? It will go to -2, -1, and 0, h of -k. So there are 5 regions. When we are convolving these two signals, there are 5 regions. The first one, no overlap. The second one, partial overlap. The third one, fully overlap. The fourth one, again partial overlap. And the fifth one, no overlap. So let me write it here. No overlap. The second one, partial overlap. Third one, fully overlap. Fourth one again partial overlap. And the fifth one no overlap. So what I did in the previous example, which was this one actually, in the first step when I convolve these two and you can see there is no overlap. What will be the output in that case? In that case the output will be 0. Why when is -1? Because at this stage there is, when this signal is way back toward negative side and this signal is on that 0 to 2 and this signal is on left hand side, negative side, then there will be no overlap. So what will be the second case? Let me draw this signal here. When I convolve this signal with this one, in the second case, let me draw it over there. As you can see, I'm using the other marker. HO minus K. So there is overlap. I have written this value as 1. So these two will multiply, then I will shift towards this one. In the next step it will move here and these two will multiply, and in next step again there will be fully overlap because these three samples will be over there and will be overlapping all three samples. Let me tell you how. So in fully overlap you have these three samples and these three samples overlap over there. This is 0, 1, 2. So as you can see that this is fully overlap. This is H of minus K and this is X of K. When we slide this H of K towards our right side, towards the right hand, and it will there will be a stage when these samples will overlap. So what will be the Y of n at this stage? 1 multiplied by 3, 1 multiplied by minus 2, 1 multiplied by 1. So what comes out to be 2. So in the next step it will, when we slide further towards the right side, H of minus K, it will again partially overlap and a stage will come, then there will be no overlap. So at that point Y will be 0. So this was all about convolution. In the next lecture I will tell you the properties of convolution and about correlation. That's it for today. Thanks very much for watching.